So I thought it'd be easiest to record this video for you to talk about this function that you picked for your Descartes rule of signs problem. So for the first one, I'm noticing that I can factor out a common factor of x, right? So since we're trying to find the number of zeros, why not do that and keep it easy? Okay, 10x plus 100. And then I'm asking myself, well, I know x equals 0. It's one of the zeros for this polynomial. The other ones, well, I've left with this. I don't really know. So let's apply Descartes' rule of signs to this. So if I just look at this, I see no sign changes. So that tells me there's no positive roots, real roots. Then if I find f of negative x on just that quadratic part, I'm going to get x squared minus 10x plus 100. And now I'm seeing two sign changes. So that tells me there could be two real roots, two real negative roots, or there could be zero complex roots. Because I am dealing with a second degree polynomial now, I don't have to worry about that. And then because these always decrease by 2, I could go with zero real roots, zero real negative roots, and 2 complex roots. Now you got to remember too is complex roots always occur in conjugate pairs. So if I have one complex root, there's going to be another one. So that's my possibility. I know x equals 0 is one of the roots, one of the zeros, and I could have two complex roots. I could find them. That's not what Descartes' rule of signs is asking me to do now, but I could substitute it into quadratic formula. X equals negative b plus or minus the square root of b squared, which is 100, minus 4 times 1 times 100, all over 2 times a. And I see, if you look what's inside here, let me get a pointer going here. Spotlight. I can see that's going to be 100 minus 400, which is negative 300. So there's going to be two complex roots in this. I also just tried to graph this in Desmos, and I'm seeing the x equals 0 root, but I'm never seeing it come back down. I mean, I'm way out at 12,000 on the x-axis, and it's not coming back down. So that tells me it's going to be a two complex roots. Okay, so Descartes' rule of signs works great, but don't apply it too early. I think if your example had been, if you had added a constant term with this, it would have worked slick. Okay, and that kind of follows through with what you did with the next one also. I see I could factor out a 5x squared out of that. I suspect the same kind of things happening there. Okay, so just pay attention to that. Think about what it's giving you. Where is it? You said right here there'd be one complex root. So that's a problem because they always occur in conjugate pairs. So, and we can do some more work with this and figure that out. I mean, I would certainly factor out a 5x squared. What does that leave me? That leaves me what? X squared plus 8x plus, let's see, 20, is that 40? And I don't know, we'd have to look and see what that's. Does it factor 40? I don't think so. It's probably going to have to use a quadratic formula for that. Okay, so hopefully that helps you work through this. And Descartes' rule of signs is a hard thing. It's a tool. It's a good tool. I don't always use it much though. Okay, so hopefully that helps you with this. Give a yell if you want to go over it.